do?
Rise over run.
Yeah, rise or run, which is even better in algebra. What would it be? So geometrically, if I have the picture, which I do here, so you can do rise, you can just count how much did it go up, how much did it go over, right? So let's try that. Let's do like the with the wind, the very first point. So they all start at 0, right? With the wind, what is this very first point there?
24.
Good. It's 24 here,
Half hour.
and this is a half an hour here. So how much did it go up? 0, 0. How much did it go up?
24.
24. So it rose 24. How much did it go over? Half an hour.
This is with the wind?
That's with the wind. Do you guys see that with the wind? The blue one with the triangles. Isn't that very first point? It's got a little triangle in it. That first point is 0.5, 24. Right? And it's really cool because it starts at 0, 0. So it just goes up 24 and over half an hour, right? So in half an hour, he will have gone 24 kilometers. So how fast is he going? What's 24 divided by a half?
12.
Here, 24 divided by 2 is 12. 48. When you divide by a half, you multiply by 2. So that's 48. 48 kilometers an hour. Since it's a straight line, does it really matter if I pick this point and that point, or this point and that point? No, of course not. It's a straight line. The slope has got to be the same. If you want to check it out.
It's easier just to go to 1. 48 and 1.
Yeah, you can do 1. What's the 1?
48.
1 is 48 here, right?
Yeah.
So he's gone up 48
Over 1.
over 1, 48 over
48.
1.
Same thing.
Exactly, I love it. Do you guys see that? If I did take 2 points and it was different, what does that mean the line is doing? Is it a straight line then if the slope suddenly changes? No. It's got to turn then, and then it's not a straight line. But these are straight lines. It doesn't matter what points you pick. So hell yes, I'm going to pick the point 0, 0 if I can. Because that's easy, that's nice, right? But actually here, you can just count up and over from between any two. So this would go up 24, wouldn't it? Over 0.5, between this and this, right? It would still be the same stupid number. It's got to because it's not turning. If the slope changes, it's going to have to turn. And then it's not a straight line. A straight line, the slope must be constant. It must be the same everywhere. So if I'm on my car going 60 miles an hour, that's a nice straight slope on my time versus position. Nice straight slope. The minute I see in front of me the traffic stopping and I slam on the brakes, now all of a sudden it's going to go. So here I am, a nice straight slope, and then it's going to go, what? And maybe turn around. Now I'm starting to slow down, right? I'm not going backwards, but I might stop. Whoop. If the slope changes, it can't be a straight line anymore. Good. Okay, maybe.
Slope changes. The line changes if the slope changes.
If the slope changes, it's got to kink. It's got to turn somewhere. If the slope gets bigger, it's got to turn up. If the slope gets smaller, it's got to turn down. Right? If the slope changes sign, it's got to go really for wah. Okay, maybe. Okay.
No wind.
So this problem, all it asks you to do is find the slope of each 3. Right? So you do exactly what we just did. So you can do it with the red circles. Right? And like you said, I would go to 1 maybe because it's easier to see that. You can pick whichever point you want to. It doesn't matter. Right? And then they ask you, once you get the numbers, if this is 48 and the one with no wind is 36, how much quicker is she going with the wind? 12 kilometers an hour. I mean, now the rest of this problem should be easy once you get those numbers. Because then they just ask you to compare those numbers you got. So part B is easy, part C is easy, and part D should be pretty easy too. If with the wind she's going 48, with no wind she's going 36, how fast is the wind going?
And I guessed with 24.
So she normally goes 36, and then the wind starts up and she goes 48. The wind must be going 12 kilometers an hour. That's where that extra speed is coming from, right? Okay, cool.
And I guessed with 24 against wind?
Against the wind would be 24, exactly.
24.
Mm-hmm. I love that problem because mathematically it's easy. but it's trying to show you how you can look at the mathematics of it and let it be easy, but at the same time they've got a real life situation on top of it. And then they can ask real life problems and real life questions. Right? But the math there is easy. Let it be easy. If I give you a graph and I say find the slope, just count up and over, right? Rise over run. So for example, if I give you one like we just did the other day. So if this is 1 point and here's another point. From this point to that point, how much do I rise? No, I fall, right? I fall by how much? 1, 2, 3, 4, 5.
-5.
The slope
Negative.
will be rise over run. If I fall, it's negative. Good, so -5, right?
Yeah.
And then I run 1, 2.
2, okay.
Right? So here, 1, 2.
Yeah.
-5/2. That would be the slope between those 2 points. So if I give you the graph, let it be easy. I don't care what the graph represents. The math is easy then, right? And then they can ask you questions about, well, this is bananas I can eat per minute or something, I don't know, right? Or the temperature over some time length. You don't care. The math is easy. Then you can answer the questions they throw at you after that. Okay. Of course, I don't think I ever got that out of you. If I don't have the graph, they just give me 2 points. What do I use then? So if they just give me 4, 7, and -3, what's I don't know, 2.
y1 minus y2 over
Yeah.
x1 minus x2. x2.
And the way you said it is perfectly fine too. People, why do they do this then? What do those little subscripts mean?
As long as you stay constant, do the same on both.
That means for this problem, these are specific values, right? A y without a subscript can be whatever the hell it wants to be. But when I have a little 2 on it, that means it better be a specific value. Does it really matter which one you call x1, x2, y? No. All this does is it makes sure that the sign comes out correctly. So if I call this one x1, y1, and this one x2, y2, I would do y2 minus y1 divided by x2 minus x1, right? So we do y2 minus y1, 2 minus 7, over x2 minus x1. Now if you call this one the 2's and this one the 1's, wouldn't this change and this change?
It would be this one.
It will be the same. Both signs change, so the whole sign is the same. So here you would get -5 over -7. You get 5/7, right?
Yeah.
Now if I looked at it the other way, it would be 7 minus 2 over -4. 4 minus -3, right? Isn't that 7 minus 2 is 5? 4 minus negative is 4 plus 3 is 7. Same stupid answer, right? So the only reason these little 2's and 1's exist is so that you go the same way. This minus this, oh, you better do this minus this. Don't switch in the middle, or else your line is suddenly going the wrong direction. Yeah, that's the only reason they have that in that equation. To make it easier, you can label it and then just plug and chug, right? Okay. Any other specific questions yet?
Page 181, number 18.
Alright, so this one says
X over 4.
graph by finding the intercepts. And they give you this disgusting looking monster. Who remembers how to find the intercepts? How do I find the x-intercepts?
Set y to 0.
Beautiful. Never forget that. It's that easy. Don't make too much out of it. To find an intercept, make all the other letters 0. We're only going to have 2 letters. Great. So to find the x-intercept, let y equal 0. So if y is 0, I get x over 4 minus 0 over 7.
0.
And what's 0 divided by 7?
0.
So I get x over 4 equals 1. How do you solve for x?
You multiply by 4,
Multiply by 4.
both sides.
X equals 4. What's the point then? What's the intercept?
What, 4?
4,
0.
0. That's the x-intercept. I'll let you get the y-intercept. Same way, right? So you guys might realize x-intercept, cover that. So y-intercept, cover that. So, because what's going to happen when I find the y-intercept? I'm going to let x equal 0. This whole piece dies. Somehow I always have this piece stay alive. Somehow 0, that's going to die. Gone. Let it die.
And y, what is equal y?
So,
Zero.
see, sorry, yeah.
Okay.
So it's a 4. Yeah. 4 is in 0.
And the points,
So now the y, to find the y-intercept, you would let
y equal
x equals 0, the other letter.
We said,
Could you just get rid of the fractions, right, straight from the
You
beginning?
could, but do you see how that really is actually more work here?
Right.
Why? And getting rid of fractions, I normally want to do that, but here I'm letting a whole piece of it go to 0. It actually is easier not to.
Right.
Because I'm actually simplifying. I'm allowed to simplify part of my equation right off the bat. Let x equal 0. This whole thing goes away. Because 0 divided by 4 is 0. Then I just multiply by 7.
Negative y.
And actually I can multiply by
Y.
negative 7 to kill that negative also. Right?
Oh, negative 7.
Multiply by negative 7. That cancels, 7 cancels. Y equals negative 7. What's that point?
0, negative.
X is 0, y is negative 7. Now go and graph those two, connect them. You'll be done. Yeah.
333.
Okay. Oh, good. So y equals 2x is part A. B is x equal negative 3. C is y equals 2. So again, if you know slope of y-intercept, we haven't officially gotten mx plus b yet. You could do it here. If you don't remember it, or you want to go by the book and you want to look at just this chapter, you can make a little XY table here, right?
I couldn't find nothing in the book to cover this.
Oh, sure, it covers everything. Because when you have a function, you don't know what it looks like, what do?
X, Y.
Make an XY table.
I was beating my head against the wall.
Oh, don't do that. It'll leave a mark. Like on page 176, for example. That's a pretty good one right there. They got a little table. They give you this y equal negative 1/3 x plus 2, and then they make a little table. Right? So the idea with the table is, I know how to graph points. So if I can give myself several points to graph, that's easy, and then connect them, and I'm done. So how do I make points? Points are